So our next presenter has a long history with cyber espionage and targeted attacks, which when I read that, I was like, what exactly does that mean? But I'll leave it to him to answer. Robert Falcone is a threat researcher with Palo Alto's Unit 42 and has spent the last 10 years focusing on malware analysis, reverse engineering, and tracking threat actors, primarily those associated with cyber espionage and targeted attacks. He's also worked as a security engineer within an operations center for a managed security service focused on intrusion detection and prevention. Please welcome Robert Falcone.
Thank you, everyone. So, thank you, Rich, for that introduction. I'm not going to really introduce myself because that was a pretty decent job. What I do want to say is that I'm a threat researcher. Okay, so I'm going to be talking about a specific threat that we've been researching for a while now, called Sofacy, and I'm going to talk about how we're using attack when we're doing this kind of threat research, and specifically with one of the concepts we're starting to really focus our attention on, and that's adversary playbooks. Okay, so I'm going to start off talking about adversary playbooks, the concept behind it, and I'm going to start off by asking probably the most important question of this entire conference, and it's did anyone back late '89, '90 play Nintendo? Does anyone know what this game is? Wow, that's a pretty decent amount of folks. Okay, so for the folks that don't know what this game is, this is, what's that?
Right age group.
Okay, yeah, I know, right? In the right country, American football. So this is, for those that don't know, this is Tecmo Bowl. It's a football game on Nintendo, and I think there was a Super Nintendo version. But the idea was there were two players here, and one player was on offense and one player was on defense. And the offense would try to choose a play from a screen like this, and it would be like a run player, pass player, whatever. And the defense would try to pick that same play, okay? And if the defense picked the same play, they overwhelmed the offense and just dominated them, okay? Just like this. So even though this is, Bo Jackson about to get the ball, he gets crushed. He's not able to get, anywhere. And I'm using this metaphor and this analogy because that's where we want to be by using adversary playbooks. If you know what play the adversary is going to run to attack an organization, you're going to have a much better chance of defending against it. So let's get away from Tecmo Bowl for a little bit. Let's talk about how we decided to approach this problem and to make this no longer a concept, but actually put it into reality and put it into our workflows as threat researchers. So we started off with the attack lifecycle, just because that's how, as researchers, we are focusing on how an adversary is going to carry out their attack, and it's just a phase-based approach. You may know it as the Lockheed kill chain or whatever. But again, it's just a phase-based approach. And what we did was we wanted to use the attack framework to be able to identify the activities that an adversary is going to have to take in each one of these phases. And we wanted to be able to share this with the community, because that's a big part of Unit 42, is that we want to share the intelligence with the community for a greater good. So we ended up using STIX version 2 to be able to create objects for each one of these attack techniques and be able to apply it to the kill chain. Okay. So you guys probably recognize this. We've been talking about it for 2 days, so I'm not going to talk about it much. But I just want to take this time to thank the folks at MITRE that worked on attack and all the contributors, because this saved, without this framework, the playbook concept would never have gotten off the ground. So thanks, everyone. I appreciate that. So I mentioned that we're using STIX to be able to disseminate these playbooks and disseminate this intelligence out with the community. And I mentioned that we're specifically using version 2. And there's one main reason that we chose version 2. It's the latest and greatest, but it's also in JSON format, which is really, really helpful because we don't have to parse XML anymore. We're going to start using JSON objects to be able to identify the entities within these playbooks. And one of the other really important parts about STIX 2 is that you can relate any entities together or other JSON objects together using a relationship object. And this is actually really important because this allows us to kind of bind things together to actually be able to create these plays and playbooks. Okay, so how did we approach this? Well, like I said, we took the attack lifecycle, we took the attack framework and pre-attack, and Sticks version 2, and we kind of threw it in a blender just to see what we could come up with at first. And I think it actually worked because we're starting to be able to create these playbooks during our research efforts. So here's how we actually looked at the playbook concept. So at the top here, we have an adversary or intrusion set or whatever you want to call it. And underneath that, they're carrying out attack campaigns, right? And each one of those campaigns has a set number of techniques that they're going to carry out to carry out that campaign. And each one of those techniques may have a set amount of indicators that you can look for and observe to be able to see that technique happen. So in our playbook idea, we just kind of replace some of these words with these words instead. So at the top, we've got the adversary now being the playbook, because if you think about it, an adversary wouldn't have multiple playbooks. If we continue that analogy with the football team, a football team wouldn't have multiple playbooks. That doesn't really make sense. They would just have multiple pages of plays within that playbook. That's why campaigns themselves are plays. Getting back to the techniques themselves, we just mapped, like I said, we used the attack framework. We just made that mapping very easily. And indicators themselves are just Sticks version 2 indicators, which are just indicator patterns that what we're able to do now is we're able to use Sticks relationships to be able to bind all those together, make those relationships between Sticks indicators, observables, to the actual techniques that you can identify with that indicator, and be able to relate all these things together. From there, we use another Sticks object called a bundle of sticks, right? I think that was a Sticks joke. But so what we were able to do with a Sticks bundle is we're able to take all these JSON objects that are related to a play, a playbook, the attack techniques that were used in that play, and all the indicators, and we're able to put them in one object to be easy to be shared with the community. We can just create one object and share it out as one giant JSON object. Okay. So I mentioned that we're using Sticks version 2, but we're also mapping the attack techniques to the kill chain. And I wanted to provide a quick mapping of how that works. We just did a really very simple, very dirty kind of attack tactic to kill chain kind of mapping, and it kind of worked out, okay, for the most part. You probably can't read all of these, but some of them fall into multiple phases. Specifically, I think it's execution. Has some techniques that really belong in the exploitation phase. So we had to kind of make decisions on where these techniques actually fell on the kill chain. And luckily, because we use Sticks 2, these are all JSON objects, we can manipulate them a little bit. Like right here, you can see we're able to assign not only the kill chain name for the attack tactic, but we can also change which phase on the Lockheed kill chain it actually belongs. And you'll see this when I show you our viewer, why this is important. Okay, so this is a playbook. Doesn't that look great, right? Humans should never read this. This is the JSON output of our playbook creator, right? But I just wanted to emphasize, this is really good if you're a machine and need to parse this really quickly, because they're all really concise JSON objects, really easy to consume from a machine standpoint. I also mentioned that humans shouldn't read this. We actually created a viewer that will parse all of this for you and actually make it so your eyes don't bleed. And I'll show you that in a little bit. Okay, so what I'm going to do now is I'm going to talk about a specific threat actor called Sofacy. I think someone touched on this threat group earlier in at the conference. But I want to talk about this specific threat and use this threat as an example of how we're building these plays and playbooks for their campaigns. So let's jump off into some of the activity that we saw this threat actor carrying out in early 2018. Starting in January 2018, moving to February, another attack campaign in March 2018. I don't have time to go into all of these, but I want to focus on one that occurred, one campaign in February 2018 that we internally call Lucky Strike, okay? This was targeting government organizations in the EU and in the North America, okay? So we call it Lucky Strike internally because of the tool that they use to create the delivery document, okay? So what I'm going to do now is I'm going to go through each one of those operational phases and what the adversary actually did in each of those phases. So then afterwards, we can actually build a play using the attack framework, okay? So let's start in the weaponization phase. Like I said, this group used this tool called Lucky Strike. I'm not sure if you guys have heard of it, but it's an open source tool. It's freely available on GitHub. And what it does is it takes an Excel spreadsheet and adds a macro to it and embeds a payload to it of your choice and outputs another weaponized Excel document. Pretty straightforward, okay? So this group used that to generate their delivery document that then they deliver via spear phishing email as an attachment. And this is what the email looked like. And the interesting part about this is the delivery email itself spoofed a very well-known organization in several different industries. And the actual content of the email was written really well, really decent spearfish here. Let's move into the exploitation phase. Let's look back at that delivery email. You can actually see there's this spreadsheet attached to it, and I drew a box around this part of the email. It says, note if you're having trouble viewing the document, you can try to enable content to resolve the issue. Now, many of you may know macros are not automatically run in Microsoft Office products. You actually have to click the enable content button to run it. This is just giving you a, hey, if you can't see the contents of the document, try clicking enable content. It may fix it. Well, guess what? It does. So when you first open it, it looks like this. No content in it. But once you click the enable content button, all of a sudden you see the content. So I mean, you're seeing, the email was right. Now you click the enable content button, it resolved the issue, everything's grand, right? But unfortunately, what you did was the macro ran, and the first thing it did was it just changed the color of the text to black. Okay, so if you were just to highlight all of those cells, it would have showed up, and because you'd be able to see it, it was just in white text. Okay. However, the macro itself also installed the Trojan, and this is the code that would obtain the embedded payload from within the spreadsheet. Then the macro would take that encoded data, write it to a text file, and then use the cert util decode application, or in this case the switch, to decode that base64 encoded data and write it to an executable, which it would later run. Okay, so that's the installation process that would occur. Now the payload that was dropped was Sofacy's pretty much go-to first stage payload. Some folks call it setup loader. We call it Sofacy Convert, but it's their primary go-to first stage payload. So that initial payload in the command and control phase would use HTTPS to beacon its C2 server. And it looks like this. Well, technically it's in HTTPS. This is just the HTTP request that's going out. As you can see, it's just an HTTP post request to a specific domain, has some ciphertext in it, and that's a C2 channel. Let's move into the objective phase. And I will be honest, we don't have a complete view of what was going on here. We didn't see any lateral movement. Because what we found was that when we took a look at the data that was sent out in the C2, it looks like this, which is encrypted. Once you decrypt it, you can see initial local reconnaissance being done. Running processes. It's checking the hard disk and some of the NIC information, that kind of stuff. Also sending a screenshot that is meant to filter out, analysis systems and that kind of thing. Okay, but what we can surmise based off of the command handler of that payload is what they're actually trying to do. This is just, like I said, their first stage payload. All they're trying to do is to, do initial reconnaissance, find out if that's the system they want to compromise, and then they load additional tools to be able to carry out further activities like lateral movement, privilege escalation, that kind of stuff. So now we've gone through that whole process. That was the Lucky Strike attack, looking at it from the kill chain perspective. Now, I want to use that same attack and talk about how we created a play for our playbooks using that information. And I mentioned earlier when I showed that JSON that would make your eyes want to bleed. This here is the viewer that we created to parse all that JSON to make it so a human can actually click through these playbooks and understand what TTPs are being used in the lifecycle. You can access it right on our GitHub page. There's the link right there. So if you're interested in kind of playing around and looking at the playbooks that we have and the indicators that are associated with them, you can just go right to our GitHub. Also, the raw JSONs are also freely available on our GitHub as well, so you can do whatever you want with them. So let's go through the same lifecycle phases and kind of highlight which one of the attack TTPs that were in those phases. Now, I'm not sure if anyone's still playing bingo, but there's going to be a lot of attack techniques here, so you may win. And if you win, please shout out, because I do have a prize. So if you win, let me know. Okay, so in Recon, we have the identifier business relationships from pre-attack. And the reason why we have that there is because the actor clearly was able to identify that there was a relationship between that spoofed organization and the targeted org that would help them be successful in their attack. Moving on to the weaponization phase, we have these techniques here. And I'm just going to highlight the by domain name. In the black text here, you can see it's newly registered domain. That is our description in our play for the reason that technique is in that play. Okay, so we're able to provide a little bit more insight for the viewer why that is there. And below that, you can actually see the indicator, the Stix version 2 indicator that we created that is now is related to that attack technique right there. So if you were to see that domain cdnverify.net, you would know exactly where or what adversary it's associated with, where in their operational phases it belongs, that kind of thing. Okay, moving on to the delivery phase. There's some interesting techniques here, which I'll talk about in a little bit. But here we have spear phishing messages with malicious attachments. And as you remember, the Excel spreadsheet was attached to an email sent to the target. And here you can see there are several different indicators associated with that specific technique. Moving to the exploitation phase, another interesting technique. Authorized user performs requested cyber action. This was to capture there was no software vulnerability that was exploited, so we had to use a technique from attack to specify, clicking that enable content button to infect themselves, and that's what this is used. Okay, in the installation phase, here's several different techniques that were used, and I'm just going to highlight this one real quick. The login scripts is a very specific registry key that was used by the payload to automatically run each time. And here at the bottom, I just want to kind of highlight in orange. You can see that the actual indicator pattern itself includes some logic. There's an and in there, right? So I just want to highlight the fact that Stix2, you can actually write some pretty accurate indicator patterns by using a little bit more logic to them. Like this one requires a registry key and a specific value being used. So interesting stuff. Okay, moving into command control, we have standard application layer protocol. One of my favorite techniques, which you'll see in a minute. Sofacy burp uses HTTPS, and there's the technique that's being used. And in act on objectives phase, these are the techniques that we were able to just kind of speculate on because we didn't have a true view into what they did after they got their initial access. But this is what they did right when they got to the system. One thing I do want to highlight is the fact, usually when I give this presentation, I go through multiple of the different campaigns so you can start comparing them together. But once you do this kind of create these plays and start tracking the techniques that are used during these campaigns, you can start seeing overlaps in different campaigns by the same threat groups. So it shows that they continue to use the same techniques over and over again in their attack campaigns, which is kind of interesting. Okay, so I don't know how much time I have left, but I want to talk about a little bit about the challenges that we came across when we were creating these playbooks. This is not a bash fest. I love attack and the framework itself and sticks. But when we first set out to make this concept into a reality, we came across some hurdles that we kind of had to overcome. First off, standard application layer protocol is a good example of where a technique is a little bit too broad. So in our plays, this doesn't really tell you what standard application layer protocol, right? It could be, in this it even says RPC, SSH, RDP, all those kind of things, right? Luckily, we were able to kind of overcome this in our plays because we're able to add descriptions, so we were relying on that. But this was an interesting one that showed that some of these are really, really broad techniques. Execution through API, very, very all-encompassing. Because this pretty much captures almost any Trojan that runs on something else using an API like create process or WinExec or load library, anything. So any Trojan that loads something else would be captured by this technique. So this would pretty much show up in almost all of our plays. Use of open source tools like the Lucky Strike attack that I just mentioned. There isn't a technique for that. And I know that the MITRE folks are really receptive to new techniques, and we've been kind of going back and forth about this one because we don't know if it's really a technique or not, but it is the flip side of using custom tooling. So there's a conversation to have there. And my favorite, and this is a lot on us because I know that several of the techniques have been deprecated. As you probably noticed in my talk, a lot of that play, some of the techniques have been deprecated. And so it's one of those things that now we have to go back through all of our plays and find the techniques that were deprecated and figure out what to replace them with in some sort of formal manner. Because quite frankly, there's not like a really one-to-one kind of, oh, replace this one with this. So we have to kind of go back and do some legwork there. Okay, moving on to sticks. I like sticks. It's fun. Just sticks 2 is great because it uses JSON instead of XML. It's lots of documentation, so the information is out there. But there's like 8 or 5 different documents. They're all like 70+ pages, and there's a lot of control F going on here to be able to find anything that you're actually looking for. Okay. That being said, there are things that are sort of missing here, especially with the indicator objects. There's these things called cyber observable objects which you use within your patterns. And in this case, there's an object for HTTP request, but there's no object for HTTP response. So you can't write any patterns for anything a C2 server would reply with because there's no object for it. Okay, Sticks 2 is great because it actually comes with a Python library, and which allows us to create things really quickly. And one of the things that we ran into from an issue standpoint was the pattern validator itself was pretty broken. Fortunately, the Sticks folks were able to fix that with a new library. But for a while there, we weren't able to create any indicators with a double quote in it. It just would break and it wouldn't work at all. So here you can see it just had a traceback error when I tried to create that. And this is one of the patterns we try to create for this specific play, that Lucky Strike play. But we weren't able to because of this limitation. But like I said, they fixed it with their new library. Okay, I'm not going to really talk about the Attack Navigator much. I wish this tool existed when we kind of first started going down this path because there wasn't a way to really visualize and interact with the attack framework in any sort of way other than in the wiki itself. And this is actually a really cool tool that allows you to kind of interact with it. And this is that same play. All these boxes are the same play that were on the that I built in the Playbook viewer, but just using the attack framework or the Attack Navigator itself. Okay, that's all I've got. I did want to kind of end and just say that as Unit 42, as we're going through our research, we're starting to think about attack and the attack techniques and the adversaries and how they're using these techniques to carry out these attacks. and we just wanted to be able to disseminate that kind of information to provide more context to the intel that we're gathering on a day-to-day basis for the community to absorb. And yeah, that's all I got. Here's the, again, the URLs for the Playbook viewer and our blog, where most of the other information that we have. And thank you. Do I have time for questions?
Yes, you do. So,
good. Any questions?
By the way, as the guy who created Stix and Taxi, I will cop to Stix 1 being something I will take to my grave. But glad to see that you've toughed it out and stuck with Stix 2.
Stix 2 is very, I mean, JSON's much easier to work with. And as much as I kind of gave challenges up here, it's still, well, these are standardized frameworks. Like, it's still better than me creating our own. So, I mean, you still have to give thanks where thanks is due, right?
Yeah, no, but it's an awesome application. All right, questions for Robert? Come on, you can do it.
What would you say was like the level of effort that it took to like put together one of these playbooks, to do all the mappings? Is it like a month, a week, a day?
That's a great question. I think at first, to get this process started, I think I was given a timeline. The first one had to be done in like a month. And that was daunting at first because we didn't have any tooling to be able to create these in any sort of manner. So there was some development effort up front. So the effort level was daunting at first. But since we've actually started to do these in more repetitive function and got more familiarized with not only Stix 2 but also the attack framework, it's been easier. I will also say that the tooling we have now is much better than the stuff I wrote, because it was really poorly written. But just getting familiarized with the framework and that kind of thing was probably the biggest hurdle. I will also say there were a lot of arguments between analysts, like, oh, does this apply, that kind of thing, between techniques themselves. But yeah, I would say at first it was a heavy lift, but then after a little bit, it got easier.
I have a two-part question. There we go. The first is, have you guys written software for the ingest of the data, so the actual data import? And the second, how much adoption have you seen from the community? Have you seen other people writing these and using these?
So ingestion, not yet. We're actually thinking about even creating tools to create them yourselves. How much adoption have we had? We have some serious interest in it. How those folks are actually using them, I'm not entirely sure. But we are having people, pulling down the JSONs and kind of getting excited about it. Else?
Could you talk just a little bit more about the process you guys are using to evaluate the malicious activity to create the playbook? And is there any automated processing that you're doing to identify the attack techniques being used?
No, not yet. I should also mention that this is we're still working on this. In fact, our tooling is not even fully there yet. We do have ideas on how we could start automating some of these things, but it's not there. Right now, it's up to the analyst as they're going through their research efforts to identify which techniques are being used and then apply that to the play. So it's largely manual right now, but we're working on it.
Any other questions for Robert?
Great.
All right.
That's done.
Please join me in thanking Robert.